Those are equations that have a radical in them. The most important part of a radical equation is to know whether or not to check for what's called an extraneous solution. And what that is a solution or answer that you might get, but it does not work in the original equation. Now, before we were solving equations, we didn't really need to check our answer, like to plug it back in to see if it works. But in radical equations, we do, because you may get an answer, but it may actually be extraneous. So let's start with number one. I got the square root of 2t minus 1 is equal to 1. So the very first thing I want to do is to get rid of the square root, so that way I can go ahead and solve both sides for t. So I'm going to square both sides of my equation. Doing so makes the root go away on the left side, so I'm left with 2t minus 1 is equal to 1 squared is just 1. Continuing to solve for t, I'm going to add 1 on both sides. Get 2t is equal to 2. Divide both sides by 2, and my t should be equal to 1. And I say should be because I still have to go back and check it and make sure it actually works. Question on the solving. Alright, so now I want to check it by plugging it back into my original equation, so before I even took the square root off. So I've got the square root of 2 times my t is 1 minus 1, and that should equal 1. So simplifying the bottom, 2 times 1 gives me 2. 2 minus 1 leaves me with 1. And again, that should equal 1. And the square root of 1 is 1, so that works. Now, you may say, well, you could also have negative 1 and negative 1. That is true. But when you're dealing with a radical equation, you only look at the positive case. So I don't need to take into account that I can have negative 1 as a square root as well. If I had the little plus or minus sign, then yes. But other than that, we just consider the positive. So t equals 1 is my solution.
Could you please move it up a little bit?
Mm-hmm. Questions on example 1? So I have the square root of x minus 1 is equal to x minus 7. Just like before, to get rid of the radical, I want to square both sides. So my left side is just x minus 1. My right side, however, becomes x minus 7 times x minus 7. Remember, when I'm squaring a binomial like that, I actually have to go back and multiply it out to get my whole polynomial. So I'm gonna go ahead and do that. So x times x gives me x squared. X times negative 7 gives me negative 7x. Negative 7 times x gives me another negative 7x. Negative 7 times negative 7 gives me a positive 49. And again, all of that is equal to x minus 1. Questions on the multiplication? Alright, so I'm going to go ahead and clean it up by combining these like terms together and get x minus 1 is equal to x squared minus 14x plus 49. Now, in order to solve this, I need to get one side of this equation equal to 0. So I'm going to subtract x and add 1 on both sides. So that way my left side becomes just 0. And I have x squared minus 15x plus 50. Questions so far? Okay, so now I got it in standard form. I got it set equal to 0. I can use the magic x to factor it. At the top of my x is going to go a times c, which is 50. And the bottom of my x will go my b term, which is negative 15. So I need two numbers that multiply to give me negative 15, but add to give me, did I say it wrong? I did. Two numbers that multiply to give me positive 50, but add to give me negative 15. Negative 10 and negative 5. Then I want to divide by my a term, which is 1. I can't simplify those any. So I have 0 is equal to x minus 10 and x minus 5. Questions so far? Now I use the zero product property to split them up and set them equal to 0. Solve them. So I've got x 0 is equal to x minus 10. 0 is equal to x minus 5. Solving both, I get 10 for x. And I get 5 for x. Now, because I have two solutions, I have to check them both in my very first equation. So I have the square root of, and I'll check the 10 first. So 10 minus 1 is equal to 10 minus 7. And again, I'm plugging that into my very first equation that I started with at the top, keeping the root on. Ten minus 1 gives me 9, so I have the square root of 9 is equal to 10 minus 7 gives me 3. The square root of 9 is 3. Since 3 equals 3, that one works. So far, I know x equals 10 is a solution. Questions on the check? Now I also have to check the 5 in the same manner. So I've got the square root of 5 minus 1 is equal to 5 minus 7. Five minus 1 gives me 4, so I have the square root of 4 is equal to 5 minus 7 is negative 2. The square root of 4, taking only the positive case, is 2. 2 does not equal to negative 2, so x equals 5 is an extraneous solution. So my only actual answer is x is equal to 10, because that's the only one that works. Questions on example 2? Okay, so in example 3, I've got x is equal to 2 times the square root of negative x minus 1. So, just like before, I would start by squaring both sides. Now, when I square this, the left side becomes x squared. But when I take care of the right side of that equation, I have to square the 2 that's outside, but I'm not squaring, well, I am squaring it. And then I'm gonna square the root separately. So the 2 squared is gonna give me 4. Squaring that root is just taking the radical off. So instead, I'm gonna put it in parentheses, negative x minus 1. And the reason for that is because the 2 is multiplying that radical. I'm not getting rid of the multiplication there, so I put it in parentheses instead of leaving the radical sign. Questions so far?
You can explain again, please.
Say again?
You can explain again.
Uh-huh. So I'm squaring both sides just like I did before. So the left side becomes x squared. The right side, I'm squaring it separately. So I squared the 2 to get the 4. And when I square this, the root is going away, but that doesn't take away the fact that this 2 is still multiplying in here. So I put it in parentheses to show the multiplication.
Okay.
Because now I'm gonna go and actually multiply that 4 by everything in here.
Alright.
Okay? So now I'm gonna multiply that 4. So I get x squared is equal to negative 4x minus 4. And that's just simply from distributing the 4. Now to solve, I still need one side of this equation to equal to 0. It wouldn't matter the left or the right, but I need that x squared to be positive. So I'm gonna take everything from the right side and add it to the left. So I'm gonna add 4x, and I'm gonna add 4. So I have x squared plus 4x plus 4 is equal to 0. Questions so far? Now I've got it in standard form. It's set equal to 0. I can use the magic X to solve it. Again, in the top of my X goes A times C. My A is 1. My C is 4, so I would have 4. In the bottom of my X goes my B term, which in this case is also 4. So two numbers that multiply to give me 4 and add to give me 4. 2 and 2. Divided by my A term, which is 1. I can't simplify those, so I get X plus 2 and X plus 2. Still equal to 0. Now I'm going to use the zero product property and solve it. I have the exact same factor, so I only need to solve it one time. X plus 2 is equal to 0. Subtract the 2 from both sides, my X is negative 2. Now I have to check it. Plugging it back into my original equation. I've got negative 2 is equal to 2 times the square root of negative 2. Mind you, this negative is coming from the original problem. My negative 2 from the answers inside parentheses. And then minus 1. Simplifying this, I've got negative 2 is equal to 2 times the square root of negative 2 becomes positive 2. So positive 2 minus 1 is just 1. So negative 2 is equal to the square root of 1 is 1. So 1 times 2 is 2. Negative 2 is not 2. That was the only solution I had. So my answer is no real solutions. Because there is some, they're just not real. They was considered imaginary numbers, which hopefully you went online and learned about over the weekend. Questions on example 3? If you don't have a lot of room left on your paper, you probably want to start a fresh sheet. Okay, so I got the square root of 2x plus 3 minus the square root of x plus 2 is equal to 2. So this is the first one. I've got two radicals on the same side of my equation. That's doing a lot. So instead, we're going to move one. We're going to move the negative one to the other side. So I'm going to add the square root of 2, or excuse me, x plus 2 to both sides of my equation. And I'm doing this because it makes it easier when you go to square things to not have two radicals on the same side. So I've got 2x plus 3 is equal to 2 plus square root of x plus 2. So I've got my radicals nice and separate. So now I need to square both sides of the equation. Square here. And I'm squaring all of that, the whole side. So not just the radicals, but the 2 as well. Unlike in the previous example, I have a plus sign here. So I'm going to do it very separate as opposed to together using multiplication. So when I square this left side, I've got 2x plus 3. But when I go to square that right side, things start looking real weird. Because I've got 2 of these sets of parentheses. So I have to actually multiply out 2 plus square root of x plus 2 times 2 plus square root of x plus 2. I use the same FOIL method as I did before, multiplying each little piece. So 2 times 2 is going to give me 4. 2 times the square root of x plus 2 is going to give me a positive 2 root x plus 2. Now notice I'm multiplying there, so there's no plus in that. It's just 2 times the square root of x plus 2. Now I'm going to take the square root of x plus 2 from the first one, multiply it here. So I have another 2 times the square root of x plus 2. And then when I do the square root of x plus 2 times the square root of x plus 2, that's just like squaring it. So it simply becomes plus x plus 2 with no root. Because since I multiplied it by itself, the root is gone. I ain't even get to that part yet. I know, that's why I said get a whole fresh sheet of paper. Because this is a doozy. That is just simplifying that part. And I still haven't finished simplifying it. That's why I say this for the end. Say this for the end. Now, I do have like terms in here. I can combine these two together because they're both the same. And I can combine this 4 and that 2 because they do not have anything attached to them. So, and this is going to look real odd. I've got x because I got this random x out here by itself. Adding the 4 and the 2 together is going to give me 6. Then if I combine my 2 like terms in the middle, that is 4 root x plus 2. Then I'm gonna bring my little 2x plus 3 all the way back down here. And have 2x plus 3 is equal to all of that. Questions so far? Okay, so now I have to go through the process to get that radical by itself. So I'm gonna subtract x and 6 from the right, put them both on the left. So minus x, minus 6, minus x, minus 6. Two x minus x leaves me with x. 3 minus 6 leaves me with a negative 3. These are gone, so it's equal to 4 times square root of x plus 2. So now, to get rid of the radical, I gotta square both sides. So I'm gonna take this x minus 3, square that. Take this 4 times the root of x plus 2, square that. So this becomes x minus 3 times x minus 3. Which if I multiply that, becomes x squared, because I'm doing x times x times negative 3, which is negative 3x. Negative 3 times x to give me another negative 3x. Negative 3 times negative 3 to give me 9. Combine my like terms in the middle. I get x squared minus 6x plus 9. Questions about the left? Okay, I'm gonna go back and do the right. On the right hand side, I've got 4 square root of x plus 2 squared. That 4 is multiplying. So I'm gonna square the 4 first and get 16. Put that root in parentheses because that 4 was multiplying that. Squaring that root just leaves it as x plus 2. Then I actually need to multiply the 16. So it becomes 16x plus 32. Questions so far? We're about 75% of the way. So now, I need to set it equal to 0 so I can solve. So I'm gonna subtract 16x, subtract 32. So I have x squared minus 22x minus 23 is equal to 0. So now it's time for the magic x. What will go at the top? Positive or negative? Negative. And at the bottom? Negative 22. So two numbers that multiply to give me negative 23 but add to give me negative 22. Negative 23 and 1. Divided by my a term, I get x minus 23 and x plus 1. So now using zero product property to separate them, I have x minus 23 is equal to 0. X plus 1 is equal to 0. So for my x's, I get 23 and negative 1. Questions so far? Alright, so the home stretch, I done got these two answers, now I gotta check them. And again, I'm checking in my original equation. And I'm gonna start with the 23 first. So I've got the square root of 2 times 23 plus 3 minus square root of 23 plus 2, and all of that should give me 2. And again, this is my original equation, so before I move the radical to the right, very first thing I wrote on the paper. Simplifying this, 2 times 23 gives me 46. 46 plus 3 gives me 49. So I have the square root of 49. Minus 23 plus 2 is 25. So I have the square root of 25. And again, that should give me 2. Square root of 49 is 7. Minus the square root of 25 is 5. And that does, in fact, give me 2. So far, x equals 23 is good. Questions on the chat? Okay. Now I'm checking with the negative 1. I have the square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 2. And again, that should still give me 2. Two times negative 1 is negative 2. Negative 2 plus 3 gives me 1, so I got the square root of 1. Minus negative 1 plus 1, excuse me, negative 1 plus 2 is also 1, so I have the square root of 1. And that should equal 2. Square root of 1 is 1, so I've got 1 minus 1 equals 2. 0 does not equal 2. So x equals negative 1 is an extraneous solution. So we did all of that and say x is equal to 23. Don't you love that? We need to write about that. Question. I know it's gotta marinate.
Yeah, these gonna be on the test.
Yeah.
Oh Lord, all kinds of questions. Hold on, wait. Start right here.
The ones on the quizzes and stuff gonna pick along like this? Oh, okay.
This is to
Great.
say Professor Smith did her job.
Oh, all right.
So, when we put this in Delta Math, just put the 1 answer, which is x equals 23.
Yes, because some of them, what it will do, and I don't even think I gave you, I don't think I gave you any with extraneous solutions, but in case I'm lying, if you have one, it should give you a separate little box that says, like, x equals blank is an extraneous solution. But if it just asks you for the solution, then yes, just put 23.
Oh,
Mm-hmm.
since the test moved, we still gotta turn our homework in on the 5th too?
Mm-mm. It goes with the test.
All right, great.
Yeah, so if you weren't here on whenever last time I saw you. The test was moved to the 10th, so the homework is also moved to the 10th. I think that was the only thing. Any other questions? Okay, if I did not see you before class started, I have your quiz and your homework to give back to you. The correct answers for the quiz will be posted sometime tomorrow so that you can, see where you made your mistake. Other than that, if you have no questions, have a good night.